watched our first video and you've come back to watch this second one, thank you very much. If not, we're taking part in a competition which aims to launch space balloons April 2015, and we're currently in the design stage of our balloon build. So we've been busy doing sketches and working out what component parts we need to buy, and also importantly what things our balloon has to have on it so that we don't get disqualified. So I thought I would use this video to capture some of that information, and I hope you guys find it interesting. We've decided to go with a helium-filled, latex-based weather balloon. So this is a highly elastic material and it should allow us to reach an altitude of 100,000 feet before popping. Hanging underneath will be our parachute and our payload, and that's where we're going to place all of our technical equipment and kit for the flight. However, importantly, we also need to have a radar reflector on board. Now this is a requirement to ensure that our balloon is visible to aircraft in the nearby area. The trick is going to be making a radar reflector that's safe and functional, but also lightweight, because we need to reserve as much weight as possible for our technical equipment and hopefully for our experiment. Within the payload, there are two vital pieces of kit. The first is the camera. Now this is a picture of an Arduino camera, and it's one of the options we've been messing around with in the lab. Ideally, we'd like to send pictures back to the Earth's surface during the flight, but also capture high quality resolution images and save them onto a memory card which will be within the payload. The only snag is we'll only get these additional photographs if we can find the balloon when it lands. The second key piece of technical kit is some means to track where our balloon is. So we can go with a global position system, or GPS, and this will use line of sight communication with nearby satellites and allow us to follow the balloon during the flight and provide some indication of where the balloon pops. However, we're probably then going to need some second communication system, possibly again satellite based, to beam us back the coordinates of where the payload lands and hopefully let us get our hands on the high quality photography stored on board. So that's the plan. Whether our space balloon actually ends up looking anything like our drawings, it'll be interesting to find out. We've also got these really grand ideas that we might try to do an experiment at the same time as taking the pictures, which might be biting off more than we can chew for the first year, but hey, we'll aim high and maybe hit the Earth with a bump in a few weeks' time. So we're now going to go off and continue to buy all the components, and hopefully in the next video I can show us some pictures of us actually putting them together. But in the meantime, thank you for tuning into the second one, and I hope to see you for our third. Bye!